Hi everyone. So we're working on Mod 6, the discussion board, and it looks like a lot of things have already been described and investigated. But what I wanted to take a look at, I can't remember who was working on the maximum likelihood, but I wanted to go back and look at just what exactly is likelihood. And I thought that might help us get into then figuring out maximum likelihood. So in order to describe what's happening, I decided to use a normal curve that I have down here because my students just are getting their SAT scores back and it's kind of interesting to look at. I thought we could use it to describe what's happening with likelihood. So the definition in the book of what likelihood is a function of the parameters of a statistical model. And it didn't really hit home with me. I had no real deep understanding of it until I did some research and I saw somebody explain it like this. And the way they explained it was first using what we already know, which is the probability of x, right? And if we have the probability of x, what we're actually finding is the area under a curve. So when I looked up the data for the SAT in Colorado, what I found was College Board just had data for 2016. So this is all coming from 2016. 1 million, the number of students who took it in Colorado that year was 1,637,589. And the mean of that data, and I was just using the math scores. So the mean of that data was 508, and the standard deviation was 112. Okay, so plus 112 minus 112, and that ends up being, I did the math here, but please let me know if I made a mistake. 732, 844, 396, 284, 172. Okay, so if we're looking for the probability, what is the probability that a student scored between the mean and one standard deviation above the mean, or they got between a 508 and a 620. What is the percent, what's the probability that a student got that? And if, of course, we know the probability is just the area under this curve. And if you have a normal curve, it's easy just to use your z-table, or what we all know is the, oh gosh, I hope I don't say this wrong. What is it? It's 34% right here, because between -1 and 1 is 68%. So just what I'm coloring in pink right here would be 34%. And that would be the probability that a student scored between 508 and 620 on their SAT. So when we take a look at what is likelihood, this is the cool part. Likelihood is not the area under the curve. Likelihood is when you take a look, you collect the data first, take a look at a specific piece of data. So if we say, what is the likelihood of a student scoring at 620, what we're going to look at is we're going to look at the output that this curve, the y value, let's see if I can draw a straight line over here. We want to know the height, the height of that function right there at that specific point, right? The output. And this made a lot of sense to me, because when you are trying to find the maximum likelihood, when you're looking at the book, is you have to differentiate it, right? Well, when you're differentiating it, aren't you just trying to find the limit of a function or its intended height, which is exactly what the likelihood of a piece of data looks like. So then I was wondering, could I actually put this into the equation and do it? So I found, if you look up here, I have the formula for a normal curve. So P of X is equal to 1 over, and then my standard deviation, so I'm going to have 112 square root of 2 pi e to the negative. And then let's say I want to find the likelihood of a 620 score. So I'll put 620 minus the mean, which is 508. Might not have left myself enough room here, squared all over 2 squared there. Okay, so what would the output be here? So when I put that into the calculator, I got my likelihood of a piece of data being a score of 620 being approximately 0.00216. So about 0.2% likelihood that someone had a score of exactly 620, given that the mean and the standard deviation are 508 and 112. And then if we wanted to go on and find the maximum likelihood, we would take the derivative and solve to be equal to 0, and we would be able to come up with our maximum likelihood, which would be, of course, hopefully 508, because in a normal curve, obviously our mean and our median, which is the maximum likelihood, are the same number. Okay, so I know I didn't, I hope that's not, nope.